This is 8.7 part 2, and we're going to continue graphing quadratic functions. So for our first example here, oh, and you should be doing this on graph paper, we're going to graph the function f of x equals negative 2x squared plus 10x minus 7. And so we also are going to find the maximum or minimum function value, so just keep that in mind as we go here. So as soon as we see that there's a negative number in front of the x squared, we know that our graph is flipped over, so it's like a frown. But in order to graph this, we want to make it look more like in the form that we're used to for graphing, which if you remember is f of x equals a times x minus h squared plus k. That'll tell us if it stretches, if it gets narrower or wider, if it shifts left or right, if it shifts up or down, and if it's flipped. So to do that, we first want to think about, I'm going to kind of move this down here now, we want to think about these first two terms as being sort of separate. So the negative 2x squared plus 10x, and then the minus 7 on the end. We haven't really done anything except for add some parentheses in right now. Then remember that in our parentheses, we want to get a perfect square trinomial, and we want it to be a just x squared. We don't want this negative 2x squared. So let's go ahead and factor a negative 2 out of just those first two terms. So we have negative 2, and then we'll be left with x squared minus 5x. Now I'm going to leave some room for myself here. I know I'm going to add something right here so I complete the square. And then I've got the, let me switch colors here, I've got the minus 7 already out here, but I'm also going to, since I added something in there, I'm going to subtract it out here so that I keep the value of my function the same. Let me move this over. So we need to figure out what to add on here to complete the square. So I need to take my b value, which is negative 5, cut it in half, and then square it. So negative 5 halves squared is 25 fourths. So we're going to add on 25 fourths here. Now, keep in mind that that's not actually 25 fourths. Sorry about that. 25 fourths. It is actually negative 2 times 25 fourths. All right? So I'm actually adding on negative 2 over 1 times 25 fourths, which is negative 50 fourths, which is negative 25 halves. So I added on a negative 25 halves to that part of the equation, so I need to subtract a negative 25 halves on the end of my equation to make sure that I'm not actually changing the value of that function. I'm going to erase my little work that I did with fractions over here. And then let's go ahead and factor this since we completed the square. We've got the negative 2 on the outside. And here we have x minus 5 halves squared. Remember, this always ends up being your b value, which was negative 5. It ends up being that cut in half. Then on the end out here, we have minus, or I guess it could turn into a plus because we've got some adding going on in here. We have negative 7 minus negative 25 halves. So this is really like negative 7 plus 25 halves. Now to add up fractions, we have to have a common denominator. So let's go ahead and multiply this negative 7 over 1 by 2 over 2. Then we'll have a common denominator of 2. So we'll have negative 14 halves plus 25 halves. So that gives us 11 halves, positive 11 halves. So all of this right here is actually 11 plus 11 halves. So let me move that work that I just did over so it's not bothering us here. So I actually on here have plus 11 halves. That's just this. So, I know this is a little yucky. What we know here from this equation is that from the negative, it got flipped. The 2 means it's more narrow than the graph of x squared. It was shifted to the right 5/2, or we can think of it as a decimal now. It's a little easier to think of that as a decimal. 2.5 units over to the right, and it's shifted up 5.5 units. 11/2 is 5.5. So this is, it's going to seem a little bit messy, but it's not too bad. At least it's halves and not, sevenths or something like that. So we know that since it got shifted right 2.5 units, my vertex's x value is going to be 2.5, and it got shifted up 5.5 units. So my y, the vertex, the y value of it is going to be 5.5. We can go ahead and put that on our graph. Go over 2.5 and up 5.5 right there. Now remember, it's flipped over. It's going to be like a frown, so we're going to go down from there. So let's plug in something a little less than the x value of that vertex. So I'm going to plug in a 1 to my function just because I figured that would be kind of easy here. So I'm doing 2 times 1 minus 2.5 plus 5.5. I'm just using this equation right here. I'm plugging a 1 in. So if you do that, 1 minus 2.5, oh sorry, and square it. I forgot that was squared up there. Sorry about that. Square it, multiply by -2, and add 5.5. We should be able to do that. You end up getting a 1. So we can go to 1 here. Now remember, this is symmetric. So since from this x value to this x value, I went down 1.5, let's just go up 1.5, and it's going to be the same y value. So if I go up 1.5 from 2.5, that is 4. So since it's the same distance away from that vertex as the x value of 1, it's going to have the same y value of also 1. So I'm going to plot those 2 points, 1, 1, and 4, 1 on my graph up here. And I'm going to say that's enough for right now because it's gonna go way lower. Let's keep going. So if we're looking at this, since this graph is flipped upside down, it's a frown, we know it's going to have a maximum value. It goes down forever and ever and ever. So it's not going to have a minimum value, but it does have a maximum value. Remember, the maximum function value, that means what's the highest y value that it gets. The maximum function value. So in this case, the highest this graph gets was right here at 5.5. So that's our maximum function value. All right, we've got one more example, and I didn't record any of that. Great. Or did I? Yay, I did. Okay. Oh, I thought I didn't record any of that. All right, so one more example here. So on this example, oh, you're going to be so happy. I'm not even going to make you draw a graph. All we're going to do is find the x-intercepts and the y-intercepts. And here's our function. F of x equals x squared minus 2x minus 2. Let's work on the x-intercepts first because it's a little more difficult. So the x-intercepts, anytime you're finding an x-intercept, does not matter what kind of graph, linear, exponential, quadratic, doesn't matter. That means set y equal to 0. Because if we remember on a graph, if, like, let's say here's a quadratic function, if it is hitting the x-axis, that means on the y-axis, we are down here at 0. So we set y equal to 0. So we're going to set 0 equal to x squared minus 2x minus 2. Now, it would be up to you on how to solve this. You could factor. I don't think this is nicely factorable. So you could complete the square. I would say completing the square is kind of nice because we have an even b value. So remember, to complete the square, first we're going to move this constant value over. So we have 2 equals x squared minus 2x, and we're going to add something on here as long as we add it to the other side as well. So to figure out what to add, we take that -2 in front of the x, our b value, cut it in half. That's -1, and then we square it. and that's 1. So we're going to add on a 1 to each side of this equation. So we are left with 3 equals, let's go ahead and factor this. It's x minus 1 squared. I knew it was minus 1 because that was my b value cut in half. It's also the square root of my new c value, which we decided was positive 1. So now if I want to isolate x and get it by itself, we just need to square root each side to get rid of that square. So on this side, we're left with x minus 1, and it equals the positive and negative of square root of 3. And then we just need to add 1 to each side. So we are left, I'm going to kind of switch the sides here, with x equals positive 1 plus or minus square root of 3. So remember, that's two numbers. So those are my x-intercepts. If I go over to 1 plus root 3 and up 0, I'm going to be on the x-axis. And if I go over to 1 minus root 3 and up 0, I'm going to be on the x-axis. So those are my two x-intercepts. You set y equal to 0, and you can either factor, complete the square, or use the quadratic formula to solve it. Let's go ahead now and find the y-intercepts. So for the y-intercepts, let's see here, y-intercepts. Well, if you're hitting the y-axis, like right here, that means on the x-axis you're at 0. So to find a y-intercept, you set x equal to 0. This is going to be great. So we've got f of x, or f of 0, I should really write, equals 0 squared minus 2 times 0 minus 2. So we just plugged in a 0 for x everywhere in that equation. So we're left with 0 minus 0 minus 2. So our f of x, or our y-intercept, is negative 2. So if we're at the point over 0 on our x-axis, we're at 0, and we go down 2, that's our y-intercept. So that one was pretty nice. All right, that is it. 12 minutes. Nice, another short one.